Okay, so now let's go on with building our circuit. So here is our breadboard. You can read the description in the handout in the Moodle for this breadboard. But just like let me walk you through very quickly. So you'll see first of all the plus and the minus lines here and plus and minus lines here. So these lines run vertically. So all these, the leftmost column are connected to each other and the minus column is also connected to each other. But be careful, this plus and the plus here are not connected. So it's your job if you want to use both sides to make a connection in between, okay? And similarly, minus sides are not connected on the two parts of the breadboard. So these are basically the vertically running plus minus. But in the center, they run horizontal. So basically this A, B, C, D, E, they are all connected to each other for a given row. So like this, so A1, B1, C1, D1 and E1, they are all on the same electrical line. F1, G1, H1, I1, J1, they are also on the same line as well. There is no connection between E to F. Okay, so basically you see this basically channel, it basically separates the left and the right. Okay, now basically then in the circuit, you'll remember we are going to use 3 resistors. 2 of them are series parallel with each other and their combination is in series with the other one. Okay, so here are my 3 1 kilo ohm resistors here. So basically you can put them, so basically you'll need to bend. Okay, so maybe I should change the focus a little bit. Like this, okay, so now it's bent as you can see. And then once it is bent, you can basically place this to the breadboard. So here's the way to put this, so basically I can place it like this. Okay, so one thing, so remember the flag. Please go ahead, if you wish, and just shorten the legs a little bit. This is good for avoiding extra parasitic capacitances and also unintended connection problems. And also it gives a much better mechanical strength to the component when it gets attached to the breadboard. Okay, so then I'll not attach this. Okay, so this is basically the top one here. But make sure you don't make it too short that the legs do not get into the spring-like connections within the breadboard. Okay, so basically make it short but not too short. Okay, so this is the top resistor, R1. Now it's time for R2. Again, so basically for R2 I can place it like that. Okay. And R3 is in parallel with R2. Okay. Again, it's bent now. Okay, so let me see if we can see this. Yeah, so here's the thing. So basically, the positive voltage, the 5 volts, will come through here, okay? It will pass through the first resistor, the current will pass through the first resistor, and at this row you can see that the bottom leg of the top transistor and the top legs of these R2 and R3 are on the same row. Since they are on the same row, then they are making electrical connections. So then the current will split into 2 and they will flow again. And at the very bottom, the bottom legs of R2 and R3 are also on the same row, so row number 10. So they will be connected on the bottom in this way. Okay, so then let's also put electrical jumper cables for the electrical measurement. So we are going to apply 5 volts. So first of all, let me use this for the ground connection. And let me use another one for the plus 5 volts connection. So it will still be connected to plus 5 volt. See. Okay. So here is my again power source. See, like red is at 5 volts and black is at going to be will be at 0 volts. So now let me connect those terminals. But of course, at the moment, the output of the power source is 0, so that I don't have any unintended short circuits or arcing problems. Okay, so then here is now my circuit. Okay, okay, so basically 5 volt and 0. And then for the output, I need to connect a multimeter to measure the voltage across R1. It means that I will need 2 more jumpers. So let me just arrange things a little bit here. So one cable, for instance, is going to be right here, and another cable will be at the bottom leg of R1, like this. Okay. And here is my multimeter. By the way, it is much easier to go through the circuit diagram on the handout, so you can basically use it. But here I'm showing just like how to connect things, etc. Okay, so this shouldn't replace, this video should not replace reading the handout and understanding what's going on over there. Okay, so now I'm going to use crocodile cables in between the probes of the multimeter and the jumpers. Okay, so basically here is the like negative probe with black, and I have a crocodile cable. So I will put this crocodile cable here on the plus measurement here. Okay, so we are all ready for the experiment, but before doing the experiment, one thing please check it. The multimeter, to see if it is first of all connected to measure voltage. Yes, so basically it's measuring the voltage with upper scale of 20 volts, and also the probes. See, basically, okay, good. So let me check it. Actually, in each multimeter, there are the ones that you are going to use. There are 3 connections. So first of all, common for the ground is here, this one. And you can see on the diagrams like this one is for voltage, current, and milliamps, so small current measurements. And the top one is for 10 amps. So this is for the like large current. If you are going to measure large current, and the red should be connected to here. Just be careful. So it means that within this course, we are always going to use like this one at the top, unless you are looking at a motor, and the black one at the bottom. Okay. But one more caveat. So next we are going to do. So first we will do the voltage, then we are going to use the current measurement. Although the probes are on the same ports, we cannot, on the same port, we are going to use a series connection of the ampere meter to the circuit rather than parallel. Okay, so enough. So that now let me juice up the power. So let me just give 5 volts. And as you expect, output is going to be something close to 3.3 volts, which is within reasonable limits. In the actual experiment, you need to measure the resistances using the multimeter.